In the problem, it was stated that in 1916, Nusselt derived a theoretical relation for predicting the coefficient of heat transfer between a pure saturated vapor and a colder surface. We are presented by formula here. H is equals to 0.943 times K cubed P squared G lambda over L mu temperature difference to the power of 1/4. The problem is asking for the units of the constant 0.943. And for the given, we have H for mean heat transfer coefficient with the unit of BTU or British thermal units over hour feet squared degree Fahrenheit. K for thermal conductivity with the unit of BTU over R feet degree Fahrenheit. P for density in pound over feet cube. G, acceleration of gravity with the unit of feet over R squared. Lambda for enthalpy change of evaporation with the unit of BTU over pound. L for the length of tube with the unit of feet. M for viscosity in pound over H feet or R feet. And for temperature difference, we have the unit of degree Fahrenheit. Since we're looking for the units of 0.943, we can discard the number itself and focus on the symbols beside it that contains the possible units for the number. So we will only focus on this part first. So we write that here. For better organization and easy understanding, we can put parentheses on every variable from the formula. Now, as we put parentheses, we can already distribute the respective units of each symbol. So from K, we will replace that by BTU or British thermal units over R feet degree Fahrenheit. From P, we will replace that by pound over feet cube. For G, we will replace that by feet over R squared. For lambda, we will replace that by BTU or British thermal units over pound. We will replace the L by feet. And for mu, we will replace that by pound over R feet. And for temperature difference, we will replace that by degree Fahrenheit. Next is to distribute the exponent to each unit. Then cancel out the units that is needed to be cancelled. This pound was cancelled because it was divided by the pound squared here. And that left us with a pound. However, it will also cancel out since we have another pound here. Same goes with the feet that is to be divided by another feet here. Now, since we have certain units cancelled out, we were only left with this unit. For the next part, we will now include the 1/4 exponent in the equation. Notice that this unit is equal to this one. And so, instead of replacing each symbol with the respective units, like what we did earlier, we will now use this unit since this was a result of these units cancelled out. So, as we change this into this, we can now apply the law of exponent here. This exponent, 1/4, is going to be distributed to each of these units. We distribute 1/4 to the exponent of 4 of BTU. And then 1/4 to the 4 of hour. Then 1/4 to 8 from feet. And then 1/4 to 4 of Fahrenheit. And then that was give us a result of BTU over R feet squared degree Fahrenheit. Now, let's go back to the given formula of the problem. For us to find out the units of 0.943, 0.943 must be left alone first in this equation to be equated to its particular units. In order for us to do that, we will divide both sides with this one. Hence, that will result in this equation. For the last part, finally, we can now distribute the units. From the units of H, we have BTU over R feet squared degree Fahrenheit, which is to be divided by the units of K cubed P squared G lambda over L mu temperature difference to the power of 1/4, which has the units of BTU over R feet squared degree Fahrenheit. Then, we will do the math, cancel these things out, and boom, we finally have the answer. So, that will be all, and thank you.